Guys, today's problem is delete the middle node of a linked list. Delete the middle node of a linked list. So basically, you are given head of a linked list. Delete the middle node and return the head of the modified linked list. For example, we have given a linked list like this: 1 3 4 7 1 2 6. So length of the linked list is 7. So middle will be divided by 2, which will equal to 3. So 0 1 2 3, this element will be deleted, and after deleting this element we will return the head. So 1 3 4 7 1 2 6, and after deleting we have after deleting 7, which is the middle node, we return the output. Okay, so here there are two ways to solve this problem. First is the brute force approach. What is the brute force approach? First is brute force approach, and second one will be the optimized one. What will the brute force say? Calculate the length of the string, calculate length of the linked list, calculate length of the linked list, and after calculating the length, take mid value, in which we use L by 2, and after taking the mid value, iterate a while loop, in which what will calculate the length and take the middle, and after that go and traverse the middle, 1 0 1 2 and 3. When you got 3, then delete it. For example, go middle up to middle minus 1. Okay, because middle, when we add the middle, then we will delete, the next will be 1. Okay, so we have to stop at mid minus 1, so that we can remove this and point the pointer from this to this. So we have to iterate or traverse through mid minus 1. So we will traverse through mid minus 1, which will be 2. Okay, so this is the brute force approach. Here, if head is null, means linked list is empty, so return null. If head next is null, means there is only one element, only one, means delete that one. And by default our size will be 1, length only one element should be there at present. And after that we will iterate the while loop, and we will move the temp next, find the length of the linked list. After finding the length, calculate the middle of the linked list and temp head, and as I said you middle minus 1, up to middle minus 1 we will traverse in the linked list by doing temp next, and after that mid minus minus, and temp next will be temp next will be locate the next of the next. Okay, and after that we will return the head. So this is the brute force. And what is the optimized one? Optimized will be fast and slow pointer. Fast pointer and the slow pointer. Slow pointer will move only one step at a time, and fast pointer will move 2 steps at a time. Okay, 2 steps at a time. So if I have, for example, I have 1 2 3 4, so slow pointer is also pointing at this, and fast is also. Next step, slow will be at this and fast will be at this. Okay, so because fast is moving 2 steps, and slow is moving one step. Okay, so in this linked list, when the fast will be at null pointer, when fast will point the null, then my slow will point the 3. Okay, so by this approach we can find the middle of the point. Like if we are moving 2 times ahead, then we will reach the null pointer and the null pointer of the string, and when we reach out the null pointer, we will find the middle of linked list. So this one is the base. Head is null, then null, head next is null, then null. And slow is also pointing to head initially, and fast is also pointing to the head initially. And one more previous we have, because when we add 3, then we are pointing the 3, but we have delete the 3, so we need to maintain the previous also. Previous, why previous? Because at the point 3 is our middle, now 3 is pointing to this, means slow is here, which have the next pointer of 4, but we have to delete this, so we must have the pointer of the previous one also. So when we have a previous also, so previous having the slow at every time, and while the fast not equal to null, and while the fast of next is not equal to null, we will iterate the for loop, and slow will move one step, fast will move 2 steps, and previous ka next will be slow ka next. Okay, and we will return the head. That's it. The time complexity in both the cases is O of n, you can say is O of n. So that's it.